on the project which we tagged the Integrated Agriculture Bioenergy Model. This is led by Professor Kabasa, who is not around at the moment, but I will be presenting on something that we did. Background is, you will find out that a majority of Ugandans, we tend to use wood as fuel. And one thing is the wood fuel is becoming a bit a problem in our country. That's why energy and thoughts about renewable energy is very key. And we went in, we are calling it agriculture integrated model. We realized that the place we went in, there is a total depletion of natural resources. And when you go to Wataleja district, simply because they are in Elgon Basin, you'll find that the major activity there is agriculture and agriculture of rice. And you'll realize that where there is agriculture of rice, the trouble that they are having is lack of fuel that they use. And when we went there, it is interesting, it was found out that even they gave up in eating beans, not because they don't like them, simply because they don't have fuel that can be used to cook it. And when you go to Wataleja, you'll find that there are a lot of rice millers, and rice millers have a lot of rice husks that is dumped. And through this, the ability came in to understand that these other particular rice husks can be converted into fuel. So we went in together with our colleagues from CREC, that's Sedat, and that's Dr. Susan Ann Mer, who was one of the lead person, co-PI, together with Professor Kabasa. So when we went to Wataleja, their role was to make sure that we go through the process of converting these other rice husks into a product that can come in. And science had it that there was a big challenge. They tried it in making it in maize cob, making it in ginati husks, but the problem was converting the rice husks into a briquette. And for us, we said that based on the research that we went in, we also looked out that over 99% of these people also keep local chicken. And we wanted to integrate the two so that we can make sure that the two can go hand in hand. And we looked at it in this way. As scientists, we know that to improve local chicken, it's not all about going into increasing their breeds, but also having ability to teach people about how they can synchronize the hatching system. So the integrated model is in such a way that when we say synchronize the hatching, we are looking onto this chicken that lays eggs and sits on them and spends a lot of time sitting on them and uses a lot of heat. We are saying that we can produce a certain integrated technology that helps this chicken provide extra heat by using this other bioenergy combo, which we call bioenergy combo, so that it is in a position to provide extra heat for this chicken. Instead of every time it sits on the eggs, it runs outside to look for food. And the eggs are a bit cold, and the incubation requires heat constantly. And meaning that when the chicken goes outside, the eggs tend to cool down. And when they cool down, that's why you see our local chicken having a hatchability rate becoming very low. So we went in to have that other particular model, and it's a multiple year project. But in the first year, we went in to work on the energy, which we are calling One Health Bioenergy, that requires us to convert this other rice husk into a bioenergy briquette. So together with our partners, CREC, we went together with Glide in Wataleja. They gave us an opportunity. They fabricated a carbonator. A carbonizer is a machine that helps into converting these husks into a carbonated product. And this carbonated product, they are outside there. I brought them inside here. They put them outside, but the products are outside and the carbonated products are there. Then after getting these carbonated products, you crush them. They fabricated the crusher. Then after that, you put it into a briquette making machine. Then you use other binders. We use the 3 binders. We use the skull glue. We tried also, this is the molasses. We also tried the cassava flour. And also we use the clay soil. And we found out that the rice husks alone, carbonating them, they are a big challenge, simply because they are fine. So heat passing through and this other heat to go through that small whatever was a problem. It took longer. So the process is on. We are fine tuning to find how we shorten the time. But through that process also we found out that the briquette, you call it charcoal, that is coming out, it was very light. So to make it more productive, we included also to test with other products that are already known. So we combined those other particular things, we put them together. And through the process, we produced a briquette. This is the briquette. Heavy enough. And this briquette, when you cook with it, it can cook food by putting 3 of these. Then you cook posho and beans on the same 3. We tried it and people gave us some testimonies because it is a heavy charcoal, simply because of different things that we put in. And we went to the field and tested it. We want to test further, but our interest is into integrating it into hatchery system. And through that hatchery system, it can cook simply because there is a special sigiri, not the usual sigiris we use. So we have also provided that one outside there. This was fabricated by our collaborators in the creek. So through that process, also we are learning that we can also fabricate a heater for the hatchery system. So we are looking forward for second phase. And this second phase, it is interesting to note that for us, we applied for the second phase in Reef 3. For us, we went through the process again of being evaluated to go. So we also got that, and we are glad, and we want to thank Reef for that, so that we can be in a position to continue the process to integrate. And our interesting moment of time is to make sure that we have these other millers have their clusters. They carbonate these other particular, they take to the center, which we are trying to develop at Glide. And this one will give us an opportunity to make sure that when they bring carbonized products and we pack them, it is in a position that they cluster together, and they also have attachments with poultry farmers that we can have that moment of time where the energy is provided. And they go to the center where the incubation can take place, because I've seen that one happening where people carry their eggs to a particular place to be hatched. For us, we are looking forward to make sure that at Glide, there is that's our partner in Wataleja, to make sure that they have that center where they have all the facilities for hatching system to help, but with an intention that to help the farmers also copy the technology of synchronized hatching that they can do at their home. So we are going to have clusters being made so that they can rotate around, and with the hope that one time of Taleja will be a hub where local chicken will be produced. I want to acknowledge and thank all the partners who got engaged into this. And we are looking forward, and we had different products that came in, including also knowledge-based, like manuscripts, menus. We have a menu for synchronized hatching. Also, we have a menu that took us through to make the system to make a product like this from rice husks. I want to end up here, and I want to thank, acknowledge, and thank Professor Kabasa David for giving me an opportunity to learn along, and also the team members and the funders from Makerere University Reef, Government of Uganda. Thank you so much.